Hi everybody. Thanks for checking in today. We're going to spend a little bit more time working with congruent triangles. And we've been practicing this a lot lately, being able to prove triangles are congruent. Now, just like most things that we learn in math, we don't learn them just to be able to do it in itself, but we learn a skill so that we can use that to continue to learn more things. So I want you to take a look in your notes, okay, on this little blurb I put in here about using congruent triangles. If you can prove two triangles are congruent, then you know that their corresponding parts must be congruent as well. That's based on that definition of congruent triangles or congruent figures that we wrote at the beginning of the chapter. Okay? So take a look at this. Okay? My goal here in this diagram is to prove DC is congruent to AC. That's what I want to show. I want to show that that's the same length as this. I'm given angle 1 and angle 2 are congruent, and I'm given that AB and DE are congruent. So how do I show that DC and AC are congruent? Well, hopefully if you've picked up on it already, if I can show these two triangles are congruent, I know their corresponding parts must be congruent as well off the definition of congruent figures. So that's what we're going to practice today. We've got two proofs that we're going to do. Okay? And again, okay, it's great if we can prove triangles are congruent. It's better if we can use that to prove other things. For example, when we get further on into the year and we start studying special types of quadrilaterals, parallelograms for example, okay, we're going to know what the definition of parallelogram is, that opposite sides are parallel. Okay. But okay, are there more things that we can learn about a parallelogram? For example, what's true about opposite sides? Okay. Let me show you a little bit more what I mean by this. That's a parallelogram. Opposite sides are parallel. Again, we're not studying this yet, but I want to point out to you how what we're doing now is going to help us with this. Okay. Opposite sides are parallel. Well, what else do I know about opposite sides in a parallelogram? Well, you might be saying, we know that the opposite sides in a parallelogram are the same length, that they're congruent, that this side is congruent to that side, that this top side is congruent to that bottom side. Well, are you sure? How do you really know that? What can we do? I can split my parallelogram into two triangles, can't I? Okay. And okay, what do I know about these two triangles? Are they congruent? Well, we've got the reflexive property, they share a side. I have parallel lines, so this angle is congruent to that one. They're alternate interior angles. Same is true with this angle and that angle. These two triangles are congruent by what? Angle, side, angle. And if those two triangles are congruent, what's true about their corresponding parts? They're congruent. That means this side right here has to be congruent to that side because the triangles are congruent. It means that this side has to be congruent to that side because the triangles are congruent. So as I'm trying to make this point, we want to be able to prove triangles are congruent so that we can learn more things. We can learn things about parallelograms. We can learn all kinds of different things that we haven't even mentioned yet. So let's get back here. Let's prove DC is congruent to AC. Can I prove those triangles are congruent? Angle 1 is congruent to angle 2, that's given. Now, are those interior angles in my triangle? You know what? I'm going to do something a little bit different here. That's better. All right, let me reset here. 1 congruent to 2 given. Now, are those interior angles in the triangle or not? But if I know angles 1 and 2 are congruent, what might I know inside the triangles? Let me call this angle 3 and that angle 4. If 1 and 2 are congruent, what's true about 3 and 4? Yeah, they have to be congruent. How do we know that? Well, I know that 1 and 3 are supplementary, and I know that 2 and 4 are supplementary. I'm going to abbreviate supplementary if you're okay with that. I wrote down the wrong angles, didn't I? 1 and 3 are supplementary. 2 and 4 are supplementary. How do I know that they're supplementary? 1 and 3, what do they form? A linear pair. What tells us if two angles form a linear pair that they are supplementary? The linear pair postulate. Well, if 1 and 3 are supplementary, 2 and 4 are supplementary, 1 and 2 are congruent, that means 3 and 4 are congruent. You may recognize that as our congruent supplements theorem from earlier this year. Excellent. We have one pair of congruent angles. What else do we know? Well, I know AB. Here, let me go back to red here. I know AB is congruent to DE. That's a given. Okay, so now I have one pair of angles and one pair of sides. What else is congruent in these two triangles? Our vertical angles are. Angle ACB is congruent to angle DCE. Vertical angles congruence theorem. Now look at my two triangles. I have two pairs of angles, one pair of sides. Is this angle side angle or angle angle side? Is the side that we have the side between our angles? No, it's not. This is angle side angle. So triangle ACB is congruent to triangle DCE by angle angle side. Are we done? Was that our goal? Was our goal to prove the triangles are congruent? No, that was our goal as part of the process. Now that I know these triangles are congruent, what is true about DC and AC? The triangles are congruent. They have to be congruent. They are part of congruent figures. DC is congruent to AC. What tells us two figures are congruent if and only if all their corresponding parts are congruent? The definition of congruent figures. So we proved our triangles are congruent in order to prove that those parts are congruent. Very good. Let's look at another one. All right. We want to prove triangle ABD is congruent to triangle ACD. Now you might be thinking, what does this have to do? We already practiced this. We already know how to prove triangles are congruent. I thought we were proving triangles are congruent to prove something else. Well, take a look at these red triangles. What do we know? Well, we know angle 1 is congruent to angle 2. We know they share a side. Is there anything else I know is congruent in those red triangles? That's it. An angle and a side, a pair of angles, a pair of sides. Is that enough to know that these triangles are congruent? It's not. But what if we had something else? What if we had another pair of corresponding parts that are congruent? How could I do that? Well, do you notice those blue triangles right there? Do you know anything about those? Well, angle 3 is congruent to angle 4. They share a side. Anything else? If 1 and 2 are congruent, what has to be true about those angles right there? Don't they have to be the same? Aren't we going to make an argument like we did in the last proof where we have a linear pair and a linear pair, and those two angles are congruent, so those two angles are congruent? So I really know that this, it's hard to fit 3 arcs in there, that angle is congruent to that one, which means what's true about those blue triangles? What do we have there? Angle, angle, side. So if those blue triangles are congruent by angle, angle, side, what do we know about all their parts? They're congruent. So if those blue triangles are congruent, doesn't it mean that this side of the blue triangle is congruent to that side of the blue triangle? This has to be congruent to that. Hey, and those are also sides in our red triangles, which creates what up here? Side, angle, side. So yes, my goal is to prove 2 triangles are congruent, but to do that, we need to first prove that these other 2 triangles are congruent to get that last pair of corresponding parts that we need. We've talked through it. Let's now work through it. All right, where should I start here? I'll start with angle 1 is congruent to angle 2. That's given. You know, I'm going to name this. I'm going to call that angle 5 and that angle 6. We're going to do a similar process to that last one. 1 and 5 are supplementary. 2 and 6 are supplementary. That's because they're a linear pair. It's the linear pair postulate. Well, if 1 and 5 are supplementary, 2 and 6 are supplementary, 1 and 2 are congruent, 5 and 6 are congruent. That's the congruent supplements theorem. Now we're working on those blue triangles. So we've got 5 congruent to 6. Oops. Angle 3 is congruent to 4. That was given. What else do we have in those blue triangles? Right there. Oh boy, what letter is that? I'm going to have to do a quick erase. D. DE is congruent to DE. That's the reflexive property of congruency, which means triangle BDE is congruent to triangle CDE, and we said that's by angle, angle, side. Now what was the point again in proving the blue triangles are congruent? To help us with the red triangles. Well, if the blue triangles are congruent, I'm going to switch to red because now I'm going to the red triangles. BD and CD are congruent. How do we know they're congruent? Because these triangles are congruent, and the definition of congruent figures states that they're congruent if and only if all their corresponding parts are congruent. Definition of congruent figures. So I switched to red because now I'm working on the red triangles. What else do I have there? 1 is congruent to 2. We already said that, so I'm just going to put a mark up there reminding myself. We already said that. We have BD congruent to CD. What else do we need? Oh yeah, we had the reflexive property right here, didn't we? And that is what? AD is congruent to AD. That's reflexive property of congruency. So now triangle ABD, the red one on the left, is congruent to ACD, the red one on the right. And that was by what again? Side, angle, side. Oh, feels good. Feel accomplished. Okay. We're able to prove the blue triangles are congruent to help us prove the red triangles are congruent. Okay. Here we prove the triangles are congruent to prove that those segments are congruent. And again, that's the purpose here. Okay. Like I mentioned with this parallelogram example, there are going to be lots and lots of times where we're going to want to use congruent triangles to learn something else about some other shape or figure property of different types of geometric shapes. So there we have it. I hope this was helpful. I'll see you next time.